Policymaking is happening all the time in every nation, and it can affect everything around us. But figuring out how these decisions ripple through society is complicated. It takes time, research, manual tracking, and a lot of resources to properly model and predict how one change might shape the nation as a whole. For instance, take changes in immigration policy. It happens for a multitude of reasons, such as seeking economic opportunities, a better education, family reunification, and asylum. Immigration can fill labor shortages, fuel innovation, and boost the workforce and economy. However, it can also increase demand for public services, lead to exploitation, and cause social tension. Additionally, remittance and a smaller contribution to taxes can strain the economy, especially on local budgets. With so many moving parts, it's hard to track the effects of any tweaks in policies. In addition to inconsistent data among agencies, traditional models fail to keep track of the vast number of interconnected variables, meaning these predictions have to be made by hand, which leads to longer wait times, even by large scale teams. It's clear that traditional policy modeling is a difficult and lengthy process, but with AI's growing capabilities, this can change to become quicker and more reliable. So, can AI be the next big step in policymaking? That is what a team at WPI set out to explore, training an AI model to map out the affected variables in immigration policy changes. To explore whether AI could help predict policy impacts, the team at WPI trained a model using Llama. Chosen for its flexibility, performance, and cost effectiveness, Llama was custom trained on government reports and non biased articles and studies to identify the key variables affected after a potential policy change. For training, the team fed the AI model 20 different neutral articles, gradually feeding them in small chunks. They tested three versions: a zero shot model that received no training, a few shot model that received partial training, and a fully shot model that achieved the most accurate results. The model relies on system dynamics, which is the cause and effect relationship one variable has on others. It starts with one causal variable. The direct effect it has on another variable is a causal link. The ripple effect it has on another variable is a causal relation. Put enough of them together and you get a causal map, a visualization of multiple causal links. The model uses this exact logic to derive how a change in one variable affects other variables. It is used at each process of its answer: the input, the logic, and the output. One thing the team discovered early on is that the prompt's logic was just as important as the logic of the model itself. Each input had to be based on causal reasoning. They were phrased on hypothetical policy changes and asked for potential consequences on certain given variables. To figure out if the model's answers were any good, human evaluation was used. Reviewers rated each response and judged them based on clarity, reasoning, and causal logic. They then graded them based on these criteria, which helped guide improvements. While all this is promising, the model is still in its very early stages and cannot be used for actual decisions. It can only identify the variables that could be impacted by a potential policy change, and is not yet able to explain what the specific impact is. That being said, this is still a huge achievement and holds immense potential. That was a lot of information, but here are the main key points and findings. Training was effective. A fully trained model matched expert logic and had higher accuracy. Prompts that were more detailed and had more background information improved focus and accuracy. The few-shot model worked well for smaller and quick tests. However, the longer and broader complex prompts led to less accuracy. Still, the model showed that with the right training, AI could rival human experts and prove to be pivotal in future policy analysis. For instance, a larger, more diverse dataset could improve accuracy and reduce hallucinations. With more rigorous semantic evaluation and further improvements to Llama, we could see greater flexibility in prompts and overall accuracy drastically improve. If used wisely, AI could transform policymaking, speeding up analysis and enabling even smaller teams to test policy impacts. These tools can foster better informed debates and lead to safer, more effective decisions. And with further development, similar models can be used far beyond immigration policies, such as healthcare, education, and the economy. Bringing this kind of AI modeling to these sectors could transform policymaking across all levels. And as LLMs get faster, cheaper, and smarter, integration with current internal government modeling tools can come into play, becoming a serious aid for all future decisions. Policy changes are a slow, tangled process, but this project shows that there is a promising solution. This model goes beyond a simple chatbot. It's a tool for public good that could help support experts in safer and more effective decision making. It's a proof of concept, which, if further explored, can suggest that AI and policy can work together to improve government decisions and public trust and safety. This is the first step to achieving a better policymaking system. The tech is now here, and it is only a matter of time and how we choose to use it. A special thank you to the student led team and the project advisors, and thank you for watching. Have a great rest of your day.